Okay, guys, welcome back again. Guys, மாதிரி குழப்பமா இருக்கு guys. இப்போ பார்த்தீங்கன்னு வச்சுக்கோங்களேன், பிளான் போட்டே ஆகணும் guys. ஒரே செகண்டுங்க. பிளானருக்கு ஒரு டூல் தேடுவோமா? இன்னும் பிளான் சூப்பராக போகும். நோட்பேட் தெரியல, ஏன் நான் நோட்பேடு ப்ளஸ் ப்ளஸ் ஏற்றுலன்னு ஷிஃப்ட் டெஸ்ட் கொடுத்தா எல்லாமே சேவ் ஆயிருமோ? கேன்சல். Focus. So basically, I want to earn 20 lakhs by next. Okay. Okay. How? அப்படின்னு பார்த்தா, I can provide tech services and AI automation build websites. Okay guys, build website எல்லாம் பண்ண முடியும். So services, e-commerce app with AI and all and okay, then landing pages. Okay guys, இதான் guys நம்ம பிளானு. ஸோ steps: learn LangGraph to build AI agent for businesses. Integrate with websites, e-com websites with security guardrails. Okay, well guys, build a AI app with the build and sell apps to the clients. Completed already. I have completed building several sites using Zero base and integrating with the recipe. So only pending item is lang is AI in. I think putting the AI Okay, guys, this is our plan. Plan July. I want to publish content throughout. So I so I get சும்மா சார்ஜிபிள். ஓகே கைஸ், எல்லாம் முடிஞ்சிச்சு. இது எல்லாமே செட் பண்ணியாச்சு கைஸ். இப்போ என்ன பண்ண போகிறோன்னா, இதை சார்ஜிபிளில் மட்டும் கொடுத்து என்னென்ன வேலிடேட் பண்ணணும். Validate this. Okay. Our launch template to scale. Oh, I want to know this. I want to give my client a business transformation by my services. You already know how what are my services. So what could be useful for them, and what are the things should I need to have? You, yeah, path for me, like roadmap for me to follow, and I am also planning to add newsletter chatbot. Okay, lead generation. Okay. Okay. Guys, yun na guys. புரியுது 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 புரியுது. ஓகே 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 புரியுது கைஸ். கிளியர் ஆகுது கைஸ். ஏன் எல்லா டைமும் உனக்கு லாகின் கேட்குறாங்க?
long-running conversations. So this is going to dig into human in the loop, which builds on memory and allows users to interact with graphs or agents in many different ways. To set the stage for this, we're really going to talk about streaming first. So LangGraph has first-class support for streaming, and we'll showcase this using the chatbot we worked with in Module 2. So let's just spin that back up. I'm just going to rerun this, and you can see this is the flow we talked about previously. Now, let's say I want to stream the full state of this chatbot as it's running, okay? So in LangGraph, there's two general methods for streaming, stream and async. They're sync and async. But interestingly, there's different ways you can stream the state. So one is what we call values. So this streams the full state of the graph after each node's called. So here's a cartoon of that. We go A, B, A, B, C. Each node is only adding A, B, or C, but the accumulated full state is printed when we stream values, okay? Alternatively, we only stream updates. So that's basically just the state updates by the node after each graph is called. In this case, the first node adds A, the second node adds B, the third node adds C. So updates versus values, that's kind of the first concept to understand. Let's have a look at that. Let's try updates. So I'll create a new thread ID. I'll stream, call graph.stream here, pass in an input. specify updates, and let's see what happens. Cool. So you can see something interesting here. We get a dict, the node name, and then the state update by that node. Cool. Now we can just print state update, of course. There you go. Very nice. So then here we're just selecting the node that we want to look at, and we're just grabbing the state key as noted. So that's easy enough. Now let's try values. So this is the full state of our graph after the particular node's called. I will create a new thread ID, and I'll kick that off. There you go. So here we start with hi, I'm Lance, and then we see the full state, hi, I'm Lance, and then the AI message response, how can I help you, when that conversation node is run. So we've seen there's two different ways to stream the state. One is updates, where we just stream the updates to state after each node's called. The other is values, which is the full state after each node is called. So the difference here being when conversation node's called, in the second case of values, we see the full state, both the user input and the AI message response, printed out. Whereas when we use updates, we only see the AI message printed out here because this is what the state has actually been updated with once that node runs. So let's talk about streaming tokens. Many graphs contain LLMs. LLMs produce tokens, and it's common to want to stream the tokens as they're generated by the LLM. So we can do this with the aStreamEvents method, and the events that come out are a dict with a few different keys. So we can see there's an event key, which is the type of the event, a name key, which is the name, data associated with the event, and then there's this metadata key, which has a few useful things in it, including LangGraph node. So let's have a look at this. Create a new thread here. We'll go ahead and pass in an input. Tell me about the 49ers, as they're one of the NFL teams. Again, I just call graph.aStreamEvents, messages, and let's just print some information about each event as it comes out. I'm going to print metadata, and if the LangGraph node is present, print that out. I'll print the type of the event. I'll print the name of the event. Let's have a look at this. Okay, cool. So we see lots of things coming out here. Now here's where it gets a bit interesting. See this right here? We can see when we hit that conversation node, that's where our LLM is running. We see a whole bunch of events of type on-chat model stream, name OpenAI. So this is kind of a hint to that this is probably the events that are being emitted by our LLM, which is pretty nice within this node. So we can actually isolate those, of course, because we have all the information we need. Define a new thread here, pass in the same input. But now let's just have a few checks. So if it's an on-chat model stream event, as noted here, these are events that come from a chat model, in this case OpenAI. And, this is the key point, we can look in metadata, get the LangGraph node, and let's say we have a node in particular that we want to stream from. In this case, let's only stream from the conversation node. Now in our graph, that's the only node that actually has LLM calls in it, but you can imagine a graph that has many different nodes with different LLM calls, and you may want to isolate streaming from one particular node. You can easily do that exactly as we show here, and let's go ahead and print that out. Nice. Okay, this is cool, right? So you can see this content. This looks a lot like LLM.
காதல் செய்வோம் இதயம் ஒன்றாக சேர்ந்தது. இதயம். Sorry guys.
Answer,
சிறிய
as you might
இடைவெளி
expect.
கிடைக்கின்றமே
Pretty
தான்.
nice. So let's take this one step further, and we're going to create a new thread, same input, and same deal here, but let's just do something simple. For every event, if it meets this criteria, let's just get the data, and we'll go ahead and print this data object has a key chunk, which you can see right here, right? This is just a partial AI message. Let's get the content. We'll print that content. We'll add a little delimiter here. There you go. So now you have kind of nice streaming of just the content in each AI message chunk, which you can look at really nicely here. So let's look at streaming with the LangGraph API. So our chatbot is running locally in Studio, and the API serves the backend to Studio, so it's accessible via the SDK. And all I have to do is apply this URL, which we've talked about before. So I supplied the URL. I use the SDK to get all the graphs that I'm running. So let's have a look at them. So we can see I have this whole list of graphs. That's great. And we're going to go ahead and specify I want to look at the agent graph. And what I'm going to do, I'm going to create a new thread here. So all I have to do is client threads create to create a new thread for the API, supply an input message, and I'm just going to use stream node values just like we did before. Now let's print these raw events and just have a look at what's going on here. Okay. So these are the events coming out from streaming. I can see that I have this event metadata, event values, and I have data. Okay, so you can kind of intuitively see what's going on. This event appears to be the type. The data appears to be the payload. And that's it. The event indeed is the type. Data is the state. Pretty straightforward. So let's just run this again. We can clean it up a little bit. We'll go ahead and get our state from data, noted here. And we'll just check if there's a messages key in there. In this case, there is. If there's messages, we'll go ahead and convert them to messages using this convenient little helper. And let's go ahead and look at that. Nice. There it is. So there's your user input. There's the tool call, tool response, final chat model output. Now, because messages are such a common state when working with chat models in LangGraph, there's actually a streaming mode for messages specifically that is only supported in the API. So this is actually a really nice thing to be aware of. And let's talk about it a little bit right now. So the mode assumes you have a messages key in your state, which we've been talking about quite a bit. That's actually very common in many graphs. And these emitted events have two attributes: the event, the name of the event, data, the data associated. So that's actually the same as above. Now I want to go ahead and show you. Let's look at this very quickly here. I'm going to run with messages mode, same graph. I'm going to run agent, same input. You're going to see some interesting things here. So now the types are a bit different. You're going to see metadata. You're going to see messages complete. You're going to see messages partial. So let's kind of walk through these. Metadata, just metadata about the run. Messages complete is a fully formed messages. And messages partial are LLM tokens that are emitting from the chat model. Now we talk a little bit more about these types in our documentation, which I encourage you to have a look at here. But let me just show you kind of the key point here. This is just a minor helper function to format tool calls. And what we can do is, let's run the same thing again. But we'll just basically, if the event's metadata, we'll print that out. And if the event is messages partial, we're just going to do some processing here. So we'll basically get the data from that. We'll look at the role. And we're going to go ahead and format that output accordingly using this logic. So let's have a look at that here quickly. So here's the metadata printed. What's really neat here is you can see we're actually streaming the LLM's tool call, which is pretty nice. Okay, so you can see this is a tool call, and we're actually streaming it as it's being formatted or being generated. And then likewise, we're also streaming the AI model response. And this is the final output. The result of multiplying 2 and 3 is 6. So what we're doing here is streaming the output or messages from the chat model, whether they're tool calls or whether they're just natural language responses. Streaming allows us to emit the graph state at every step, and this sets up human in the loop. There's at least 3 really good use cases for human in the loop. One is approval. So what if we want to approve certain steps that our agent should take, like tool use as an example? Some tools are sensitive, like writing to databases or external services, and we may want to actually approve it as a human before we allow our agent to execute those types of actions. Another is debugging. So that's like rewinding our graph to reproduce prior issues or avoid future ones. And a third is directly editing or modifying the state of our graph or agent with human feedback. So LangGraph offers a number of ways to execute human in the loop. And let's first introduce breakpoints. So let's reconsider the simple agent we worked with in Module 1. And let's assume we're concerned about tool use. So we actually want to prove the agent to use any of its tools. Now, in this case, the tools are pretty trivial, but this shows the concept. All we have to do is compile a graph with this interrupt before and select the node. In this case, the tools node, which is where our tools are executed. So this means the graph will run up until this node and it will stop. You can also use interrupt after. In this case, we'll use before, but they're both available to you. So first, I'm going to redefine the tools we worked with previously. This is the same agent we worked with back in Module 1. Now let's lay out the graph. We've already seen this. And now we see something cool. I've built it with this interrupt before tools, and you see now in my tools node, interrupt before is flagged. So I'm going to run it with initial input. I'll set a new thread. And let's go ahead and see what happens here. Cool. So we see human message goes in. That's what I pass. The AI message returns with a tool call. But then we stop because we're effectively passing our input here. Our assistant or chat model responded. And because it's a tool call, we went to the tools node and then we stopped. Now, because we're stopped at a particular point, we actually can look at what the state is. And we can see what node is going to be called next. Let's run that quickly. So we can see the next node to call is tools. This is a way to confirm that we're actually stopped. Now, I want to pause here a little bit and just walk through a few of the things we've been talking about. So here's a graph. A graph's a control flow of nodes and edges. We've been talking through that quite a bit. Each graph has some number of steps. Okay, in our case, we can look above. The steps are assistant, tools, and so forth. Now, each step, as our graph executes, has a state, which is written by our checkpointer as a checkpoint. This contains the state and some other useful metadata, like we see here, where to go next, and a checkpoint ID and other things, okay? The thread is just a collection of checkpoints, okay? State snapshot is just a type for checkpoints. Now here is where we're segueing to what we just did. When I call graph.getState, I'm just getting the current or most recent checkpoint. That's all I did, get state. And we can even look at that. Let's have a look at that quickly. There it is. So you get the state snapshot. This is the current state of the graph. Pretty nice. I can also call getStateHistory to get the full list of checkpoints. Now here is where we're going to introduce a nice new trick. If I call graph.stream pass and none, give it a thread ID, it will re-execute from the current checkpoint. Pretty nice. That's exactly what we're going to do right now. So let's go down here and look. I'm going to call graph.stream pass and none, pass the thread ID. We know, based upon getState, that the current state is, I'm going to run the tools node next. I'm currently here. I have the AI message in my state. So what's pretty neat is, when I run stream pass and none with my thread ID, let's see what happens. Very nice. So let's look at this. We re-emit the current state, which is pretty nice, just as like a refresher reminder of where we are, and then we go ahead and execute the next nodes. We go to the tool node, we execute the tool, pass that back to our chat model, and we get the answer. It's pretty nice. Now let's create a new thread ID. We'll bring these all together, and we'll have a specific approval step. I'm just going to add this user approval input here, and if it's yes, just continue, just like we just did. So let's go ahead and look at this. There we go. So we get the human message in, the AI message responds to the tool call, and then we ask for our human input. So I'll say, yes, I want to continue. Then you're going to see we're just going to invoke the graph with the current thread, which will just start from our current state, which is this AI message here, and it'll continue. There we go. Re-emit the current state, and then we proceed tool message, AI message, and we're done. So that's how breakpoints work in simple terms. It's very nice, very easy to use. You can stop a graph at any node. You can then proceed or continue just by passing none with a thread ID, and it'll pick back up from the current state of the graph. Now let's talk about breakpoints using the LangGraph API. So shown in module 1, my agent is running in Studio locally. And all I have to do is go ahead and get the URL for my Studio. I can go over and show you that right now. So here we are. Here's agent. Grab that URL right here. And I'm back in the notebook. Paste that in. There we go. The assistant ID is just agent in this case. You can see here. And I'll create a new thread. Cool. Now I interact with it just like before. Pass my human message in. Now here's a new thing. I can pass interrupt before to my agent through the API. This is pretty nice. Recall previously, we had to define it when we compiled the graph. With the API, you can actually pass it in. So you can interrupt before whatever node you specify. You can pass that in as one of the arguments to the API, which is quite nice. So let's give that a shot. I'll run this. Cool. So just like before, same deal. Here's the user input. Here is the tool call. And this is the same thing we already did. Pass in none as input to proceed to say I'm satisfied. Keep going. And there we go. Re-emit the current state, the tool call. Go to the tools node, get the response back. Go back to the chat model for the final response. So the real new thing here is that I can apply this interrupt before via the API, which is quite nice. You don't always have to define it in code, but of course you can. Now let's go show that right now. Let's say I want to actually define this in code and work with it in Studio. So now I'm in the repo, go to module 1, go to Studio, go to agent.py. Let's scroll down here. Now see this compile? Let's just add an interrupt. There it is. Save this. And what's nice is we can go over to Studio and see. Just restart this. And now let's run it. There we go. So you see we hit the breakpoint at the tools node. And this is kind of a human approval step. So we can say, yes, I approve, continue. There we go. So we finish. So you can see with the API, there's two nice things you can do. One, you can actually pass interrupts via just the arguments. Let's go ahead and look back at that in the notebook. Here, you can pass interrupt before directly to stream method. And this is one way to implement a breakpoint. Or you, of course, can define it in code, just like we've already been doing in the notebook. We discussed a few general motivations for human in the loop, like approval, like debugging, like editing. We've shown the first ones. We talked about how you can use breakpoints to stop the graph and approve certain actions like tool calls. But we don't yet know how to actually edit the graph state once it's stopped, which is really that third use case we talked about above. So let's discuss it here. We know we can use breakpoints. We know we can use them for human approval. But breakpoints also give us an opportunity to actually modify the graph state because the graph is stopped, and we can manipulate and grab the state as we want. So let's redefine our agent. Again, perform simple arithmetic. And now we're just going to add interrupt before assistant. So very minor change relative to what we did before. So now you can see, same flow, except we'll interrupt before we actually run the assistant. Let's go ahead and run this. Create a new thread. Passive input multiply 2 and 3. And let's give this a shot. Now you can see nothing happens. We see the human message go in, but we've stopped before the assistant has an opportunity to do anything. Now what's kind of cool is, again, like we showed, you can run graph.getState, pass in the thread, and you can get the state. So we can see here's a state snapshot. It only contains that human message input. Now here's where I want to show you something new. We can apply state update. So here, we're going to go ahead and pass a human message that says, no, actually multiply 3 and 3. There we go. All we called is graph.update state. Now let's just go ahead and look at the new state of the graph. Here we go. So there it is. Now we have 2 human messages. Remember, when we update the state, we pass in a message, it will use the existing reducer that's already defined for this particular key, messages in our graph. The messages key uses the add message reducer, which will append messages to this key or channel in our graph, unless certain conditions are met. Like, for example, if the message ID is identical, it'll overwrite it. But in this case, I'm just going to append because I haven't passed a message ID here. So now we're passing in 2 human messages. Multiply 2 and 3. No, actually multiply 3 and 3. Now all we need to do is pass in none to proceed from our current state, which is applied by this thread. Again, let's stream and see what happens. So there we go. This is correct then. The LLM sees this updated message, formulates a tool call that says multiply 3 and 3. We get the tool message output as 9. And now actually, if we want to finish this, all we need to do is run this again because we've actually stopped again at the assistant node. If you recall, we've interrupted before assistant. So what's happened is we've gone, we've updated the human input. We've then gone to the tools node. Tools node has returned the tools output to the assistant, and we stopped again. So now to finish this off, we invoke our graph one more time. There it is. You get the final AI message. Now let's briefly show how to do this in Studio. So you can say, I'll start off and I'll say multiply 2 and 3. Now recall, we have an interrupt before the tools node here. But what's kind of nice is, in Studio, I can also manually add interrupts at any point in my graph. So let's say I want to just add one here before the assistant node. So now we'll interrupt before the assistant node, and in code I already specified a breakpoint before the tools node. So let's see what happens here. I run, and we've stopped. So let's just do what we did before. Here I'm just going to go to edit, and let's just say I'm going to change this to multiply 3 and 3. Now all I need to do is fork my thread, because I've changed the state here. So I fork, and there we go. I've gone ahead. We still have that prior interrupt before running the tool node, but that's fine. We actually like this input. It looks correct. 3 and 3. We go ahead and continue to tools. We let the assistant run because the tool node has returned 9, which we believe to be correct. We'll keep that. Rerun the assistant node, and there we go. The result of multiplying 3 and 3 is 9. So it's very easy to manually add breakpoints in your graph in LangGraph Studio just by using this interrupt. So we've clearly seen how to edit graph state in Studio. Now let's go ahead and edit graph state via the LangGraph API. So recall the LangGraph API underpins Studio. We can interact the API directly via the LangGraph SDK. And all we need to do, of course, is just pass in the URL for our local studio. We'll supply our assistant ID, we'll create a new thread, and we'll do the same as we did before. Let's add an interrupt before assistant, just like we did before. We'll pass in the same input, 2 and 3, and let's see what happens. Cool, so we've stopped, just like as expected, before we hit the assistant node, just as expected here. And again, just like we did before, we can get the current state. So there we go. We can look at the state. Again, it just contains this human message. And we can modify the state. So let's just grab that last message in our state. Here it is. This is that human message right here. And we can modify it. Say last message, content, no, multiply 3 and 3. Cool. So now we can look at that last message. There it is. So now it is no, actually multiply 3 and 3. Now again, we talked about this will just be applied as a state update given the messages reducer. But there's one interesting trick here that we've done. We've taken this existing message and only modified the content. We've kept the message ID consistent. So what's going to happen is, when we update the state here, we're actually going to overwrite the value of the existing message because we've supplied a message ID. So let's run that. There it is. We updated state. Now let's try resuming. We'll go ahead and pass none, just like we did before. We'll stream the values and we'll look at what goes on. So we proceed with the tool call, and we get the result of the tool invocation. In this case, the tool returns 9, as expected. And to finish that off, we can just call it again, input none, as mentioned before. And there it is. You get the final assistant invocation. The result of multiplying 3 by 3 is 9. Remember that we stopped here because we add this interrupt before assistant. So what happened is our assistant formulated the tool call. That went to the tools node. The tools node ran the tool call, returns 9 to our assistant. Then it stops again. And we go ahead and pick up where we left off here. And we get the final answer. So we've shown you can create a breakpoint in your graph. You can edit the graph state at a given breakpoint. But I want to show you a nice trick. What if we actually want to explicitly get user input to modify the state? So we can do that really easily by supplying what we're going to call a dummy node, which will basically be a no-op node, as we mentioned here, that will basically accept the user feedback and inject it into our graph at a particular point. So let me just lay this out and show it in detail here. So we're going to create that same agent we just talked about, but I'm going to add a little human feedback node before the assistant, okay? So before, remember, we interrupted on the assistant, and then we just edited the graph state in the assistant node. Let's just add a node here prior to the assistant that will actually allow us to inject human feedback explicitly as if this node was running. So let's go ahead and define an initial input, multiply 2 and 3. We'll create a new thread. We'll run the graph until the first interruption, which we're going to expect to come at that human feedback node, okay? Now here's where I'm going to add this input, tell me how you want to update the state. This is going to be passed from the user. Now I'm going to call that graph.update state just like we showed before. But you see this as node? That will apply this update to state as if this human feedback node ran it. That's really it. It's super simple. So let's run that right now. So okay, here's the initial human message. Multiply 2 and 3. That goes as human feedback node. Let's say I want to modify that. So I say no, multiply 3 and 3. There it is. Cool. So the tool call is modified accordingly. There it is. The tool message is returned. So we've gone back to the human feedback node. There's no more feedback I actually want to add, so I don't need to update the state anymore. So I can just continue, basically. There we go. AI responds, and we're done. So this is a very nice way to systematically inject human feedback at specific points in your graph to create what we call a dummy node that interrupt before, and you'll basically add feedback as if that node is running. And you do that really simply with this update state, pass in your thread ID, pass in the state update you want, and just call as node human feedback. And that state update will be performed as if that node was doing it. Breakpoints allow a developer to set particular nodes that the graph will stop at. And this is really useful for human approval, for debugging and replaying, for editing graph state. But what happens if we actually want the graph to be able to interrupt itself? You can think of this as an internal breakpoint, and it can be based on some condition, like, something about the state of the graph that flags or triggers what we might call this dynamic breakpoint. This can be achieved using node interrupt. We're going to talk about this right now. So first, I'm going to define a really simple graph where in step 2, I'm going to throw a node interrupt based upon some condition. In this case, it's based upon the length of the input. So it's a really simple example, but let's have a look at this. So I build a graph, again, 3 steps. It's super simple. I'm just printing the state in each case. Or I'm just returning the state in each case, and I'm printing the step. So it's nice and easy. And we'll go ahead and run that. So there we go. We can see the graph stops at the second step. It's never printed because of this node interrupt. The input exceeds 5 characters. We passed in hello world. Now let's actually convince ourselves to see that we're actually stopped here, so we can get the state, pass in the thread config to get it, run this so we can see step 2 is next, okay? And we also can look at the tasks. So the state.task tells us kind of the task schedule for the graph. And we can see that the node interrupt is logged here. We can see here's the message. So let's try to actually resume. We can run, and we see nothing happens. This is because we're actually just rerunning the same node repeatedly. Unless the state is actually changed, we're basically stuck here. So We talked a bit about how to update state. We can do that pretty easily. So we can just call graph.updateState, pass in the thread config, and let's just pass a new value to the input. We'll call it hi now instead of hello world. Now the state is high, and we can try to continue. And it works. So we proceed to step 2 and 3, now with high. So basically we've been able to bypass that node interrupt in step 2 because we've updated our state and we've continued the graph. So let's show dynamic breakpoints with the LangGraph API. So I have this dynamic breakpoints simple graph here that we defined above running in Studio. I can connect to it via the SDK. Here's the URL, of course. And I can go ahead and look. So we can see here's all my graphs, and dynamic breakpoints is here. So that's great. I can connect to it. And all I'm going to do, create a new thread. I'll specify an input just like we did above, hello world. I'll specify dynamic breakpoints, and I'll just stream the outputs. So there we go. So if we look at the current state, we just run threads.getState. And let's look at it here. So we can see that we're stuck at step 2 just like we were before. And we can see the node interrupt message is logged here. So again, we can look at what is the next node, and it's again step 2 is noted. So let's try actually just updating the state. We can do that just as we talked about previously. We'll go ahead and pass a thread ID. We'll pass an updated state of high. We'll run that. And now we'll continue. We'll pass none again. So we've updated the state, and we're going to pass it in via the thread ID. And let's see what happens. So there we go. We proceed, and let's go ahead and get the current state just to see where we are. And there we are. We're at step 4. So we finished. Breakpoints allow a developer to set state of high. We'll run that. So we've been talking about a few motivations for human in the loop. One is approval, where you can interrupt the graph and approve certain nodes. The other is editing, so you can manually edit the graph state. Now let's talk about how LangGraph supports debugging by viewing, replaying, even forking prior states. And this is collectively called time travel. Let's build our agent. Again, we have 3 different tools. We've been working with this one previously. And we'll go ahead and lay it out. So there it is. Classic, simple, kind of React style agent. And let's go ahead and run it. Pass this basic user input, multiply 2 and 3, new thread ID. And now we have the final state of our agent. Contains the human message, the AI response, tool message, AI final response. Okay. Now, if you call graph.getState, pass the thread ID, let's have a look at what happens here. Cool. So you see the state snapshot object. This is just the checkpoint at the current state of the graph. And
சரி கைஸ், இன்னும் ஒரு 15 நிமிஷம் தான் இருப்பேன் இன்னைக்கு லைவ் செஷனில். 1.5 hours லைவ்ஸ். அண்டு என்ன கதைனா கைஸ், இந்தமாரி பார்த்துட்டே இருந்தால் வேலைக்கு எதுவும் ஆகாது. அதனால தான் என்ன பண்ண போகிறோன்னா பண்ணி பார்க்க போகிறோம். பேசிக்கலி என்ன பண்ண போகிறோன்னா, இன்னொரு ஃபைல் போட்டு my_learning .ipy கைஸ். ஓகே, இது எங்கே இருக்குது? இங்கே இருக்கா? மாடியூல் 2க்கு மூவ் பண்ணிவிட்டு இங்கே போயிட்டு மாடியூல் 2. சரி, இப்போ நம்ம மாடியூல் 4 3 இன்ட்ரோ தான் யூஸ் பண்ணி பார்த்தேன். மாடியூல் 3லயே எல்லாமே முடிச்சிட்டேன் பாருங்க. ஸ்டேட் ஸ்கீமா இருக்கு கைஸ். மீன் எதுவுமே பண்ண வேணாம், டேரெக்டாக இம்போர்ட்டில் தான் ஆரம்பிச்சுக்கோங்க. அதே தான். ஃபஸ்ட்டு மார்க் டவுன் எடுத்துக்கிறேன். எது மார்க் டவுன்? இதை மார்க் டவுன் ஆஷ் ஸ்டேட் ஸ்கீமா. ஓகே, நெக்ஸ்ட்டு வந்து இதுதான் கைஸ். பேக் டு தி மாடல். ஸோ பேசிக்காக லாஸ்ட் டைம் என்ன பார்த்தோன்னா, நம்ம தான் வந்து பேக் அண்ட் ஃபோர்த் போயிட்டு இருந்தோம். இப்போ வந்து மாடலே வந்து பேக் அண்ட் ஃபோர்த்து போய்க்க போகிறோம் அப்படி தான் அவங்க சொல்கிறாங்க. இங்கே என்ன வேணால் டைப்பு டிக்னா என்னென்னு பார்க்க போகிறோம். ஓகே ஓகே, இது வந்து இதுக்குள்ள ஆமாம் கைஸ். ஸோ பேசிக்காக நேமு அதுக்கப்புறம் நம்ம வந்து இது எங்கே போட்டுக்கலாம்னா இப்படி போட்டுறோம். ஃபஸ்ட்டு வந்து டைப் ப்ரிடிக்ட் போட்டுட்டு நம்மளா இதில் போட்டுக்கலாம் கைஸ். நம்ம வந்து ஸ்டேட்டை பாஸ் பண்ணுறோம். ஸ்டேட்டை பாஸ் பண்ணிவிட்டு print of not score 1 அதில் இருக்குன்னு சொல்கிறோம். ரிட்டர்ன் என்ன பண்ணோன்னா அங்கே மேலே உள்ளது கைஸ். மேலே என்ன பண்ணிருக்கோமோ அதை இங்கே ரிட்டர்ன் பண்ணுறோம். எப்போதுமே ஒரு ஸ்டேட்டை வாங்கி அதே ஸ்டேட்டை வந்து ரிட்டர்ன் பண்ணுறோம். பட் நம்ம தேவையான அப்டேட்லாம் பண்ணிக்கலாம். அதுதான் வந்து LangGraph how it works கைஸ். நேம் வந்து ஒரே நேமே வச்சுப்போம். நேம்னே வச்சுப்போம். ப்ளஸ் இஸ் டாட்னு போடுறாங்க. சரி, இது மறுபடியும் டெஃப் ஆஃப் சரி, இது சொல்லியிருந்தாங்க கைஸ். இது வந்து மொக்க கதை தான், நல்லாயிருக்கும். எப்படின்னா கொஞ்சம் பார்க்க நல்லாயிருக்கும். நம்ம அலுப்பு பக்கமாக பண்ணி பார்க்குறதுல தான் கதையே இருக்குது கைஸ். புரியுதா உங்களுக்கு? நான் எவ்வளோ 15 நிமிஷத்துக்குள்ளே எவ்வளோ முடிக்க முடியுமோ 10 நிமிஷம் தான் இருக்குது. 10 நிமிஷம் நிமிஷத்துக்குள்ளே எவ்வளோ முடிக்க முடியுமோ முடிக்கிறேன். திருப்பி வந்து நானே பண்ணி பார்க்குறேன் கைஸ். ஓகே, மூடை மட்டும் அப்டேட் பண்ணுறோம். ஓகே கைஸ், போட்டாச்சா? இப்போ என்ன பண்ண போகிறோம், டிசைட் மோட்னு போட போகிறோம். இது ஃபஸ்ட்டு பார்த்த எக்ஸாம்பிள் தான் கைஸ். எப்படின்னா ஜஸ்ட் எப்படி ரவுட்ரு ஒர்க் ஆகுதுங்கிறதுக்கான ஒரு எக்ஸாம்பிள் மாதிரி தான். இங்கே என்ன பண்ணோம், டைப்பிங் கொஞ்சம் ஆட் பண்ணுறோம், அவ்வளோதான். ஸ்டேட்டை பாஸ் பண்ணிவிட்டு இதோட அவுட்புட் வந்து என்னவாக இருக்கும்னா லிட்டரல் ஆஃப் node underscore 2 comma node underscore 1 இருக்கும் guys. சரி, சரியா இருக்கும். அப்புறம் இப்படி போட்டுட்டோம். if random dot choice of என்ன பண்ணணும்னா இது ரெண்டுத்துல எப்படியா நான் பண்ணியிருந்தேன் கைஸ் லாஸ்ட் இதில். ஓகே ஓகே, அவ்வளோதான். ரேண்டம் சாய்ஸு அதே ரிட்டர்ன் பண்ணிடும். சப் ரெண்டு ஆப்ஷன் பாஸ் பண்ணணும். நோட் underscore 3 node underscore 3 பாஸ் பண்ணி இதை ரெடி பண்ணியாச்சு கைஸ். இப்போ என்ன பண்ண போகிறோன்னா builder equal to state graph of type அதானே கைஸ். builder dot add underscore node of underscore node score 1 நோடு தானே கம்மா நோடு ஸ்கோர் 1. இதேமாரி மூணுத்துக்கும் கொடுக்கணும். த்ரீன்னு கொடுத்துக்குறோம் கைஸ். ஓகே, இப்போ வந்து 3 நோடு ரெஜிஸ்டர் பண்ணியாச்சு. இப்போ என்ன பண்ணுறோன்னா வந்து எட்ஜு பில்டர் அட் எட்ஜ் ஆஃப் எங்கேருந்து போனோம், ஸ்டார்ட்லேருந்து நோட் அண்டர்ஸ்கோர் 1க்கு போகணும் கைஸ். ஆட் எட்ஜ். ஓகே, நெக்ஸ்ட் வந்து ஆட் எட்ஜ்லேருந்து கண்டிஷனல் எட்ஜ். எப்படின்னா அந்த இதை வச்சு டிசைன் நோட்டில் வரதை வச்சு நீ ஓகே பில்டர் டாட் ஆட் conditional edge node underscore 1 comma that decide mode. இப்போ நம்ம என்ன பண்ணலாம், மறுபடியும் டாட் ஆஃப் நோடு 2லேருந்து வந்தால் எண்டு கொடுத்துடலாம். அதேமாரி நோடு 3 இருக்குங்க. சாரி, எண்டு வந்து எப்படி இருக்கணும்னா ENDன்னு இருக்கணும். இதான் கைஸ். இப்போ வந்து நம்ம கம்பைல் பண்ணலாமா? கிராஃப் ஈக்குவல் டு கம்பைல். சரி, அவ்வளோதான் கைஸ். நமக்கு இந்தமாரி சேமாக ஒன்று கிடச்சிட்டு கைஸ். இப்போ என்ன பண்ணுறோம், இன்வொர்க் பண்ண போகிறோம். கிராஃப் டாட் ஒர்க் ஆஃப் என்ன பண்ணுவோம்னா பாஸ் பண்ணுவோம் நேம் ஆஃப் விக்னேஷ். இது வந்து டேட்டா கிளாஸ்லேயும் பண்ணலாங்கிறாங்க. ஒன்லி திங்னா அது டேட்டா கிளாஸாக இருக்கனால இப்படி வரும், மற்றபடி எல்லாம் வச்சு. பட் இங்கே பாஸ் பண்ணுறவே இப்படி போடுறாங்க. ஐடென்டிக்கிலேருந்து வேலிடேஷன் எரர் வந்து ஆட் பண்ணலாம். ஜஸ்ட் அதுவும் சேம் தான். அவ்வளோதான் கைஸ். நெக்ஸ்ட் என்ன பண்ணுவோம்னா நினைக்கிறேன். பட் வி ஹாவ் டைம்னு கேட்டிங்கன்னா டைம் சத்தியமாக இல்லை. 10 நிமிஷம். அதில் ஸ்ட்ரெட் ரெடியூசர் என்ன பண்ணுவோம், ஓகே. புரியுதா? இங்கே கண்டிஷனல் எட்ஜு கிடையாது. இது இங்கே ஏதோ பேரலாக ரன் ஆகி ரெண்டுமே எண்டுக்கு போயிடுங்கிறாங்க. ஓகே, இது ஈஸி தான் கைஸ். வந்து பண்ணுறேன் கைஸ். ஸோ நேரோட ஸ்ட்ரீம் முடிச்சிக்கலாம். ஸோ பேசிக்காக நம்ம பிளான் இதான் கைஸ். எனக்கு வீட்டில் கொஞ்சம் பிரச்சனையாக இருக்குது. அதனால் நம்ம என்ன பண்ண போகிறோம், நான் கொஞ்சம் காசு சம்பாதிக்கிற வேலையை பார்க்க போகிறோம். என்னால் என்ன பண்ண முடியும்னா நிறையா பண்ண முடியும். அப்படின்னா ஒரு வெப்சைட் வந்து ஒரு கம்பெனி ப்ரொவைட் பண்ணலாம். பட் அது வந்து நான் வந்து ஒரு இம்பேக்டாக இருக்கணும் கைஸ் நம்ம பண்ணுற விஷயம். அதுதான் கைஸ் முக்கியம். சும்மா எல்லாராலையும் தான் வெப்சைட் கொடுக்க முடியும், நம்மளாலையும் தான் கொடுக்க முடியும்னா அது பண்ணக்கூடாது. டிஜிட்டல் ட்ரான்ஸ்ஃபர்மேஷனே கொடுக்குறோம் ஒரு கம்பெனி எடுத்துக்கிட்டு. ஸோ அதான் கைஸ் பிளானு. ஓகேவா? பார்க்கும் கைஸ் என்ன பிளானு. பட் இனிமேல் இதான் பிளான் பண்ணியிருக்கேன். இந்த LangChain கோர்ஸை மட்டும் முடிச்சுட்டு அதுக்கப்புறம் கொஞ்சம் ஏஐ ஏஜென்ட்லாம் பண்ண இந்த இகாமர்ஸ் ரிலேட்டடாக உள்ளதெல்லாம் பண்ணிவிட்டு தென் வந்து என்ன பண்ணுவோன்னா அதை வந்து எப்படி அந்த அப்ளிகேஷனோட லிங்க் பண்ணலாம் அதேமாரி பார்ப்போம் கைஸ். ஸோ இதான் கைஸ் பிளானு. லெட்ஸ் see கைஸ் என்ன பண்ணலான்னு. ஓகேவா? ஓகே கைஸ், தேங்க்யூ.